distance in space. How do we know how far stars, sun, our planets, distant galaxies, how scientists calculating the distances when we can't go and measure them? Let's talk about that. In the previous video, we talked about how first scientists measured the size of the Earth. Please check that video if you're interested. Back in the Greek times, the size of the Earth gave a lot of clues how to calculate other distances and sizes of planet bodies in the space. If you think about it, if you know the one value in your equation, you can find out the other unknown values. That's exactly what Aristarchus did back in the day after Aristophanes found out the circumference of the Earth and the size, approximate size of the Earth. What he did, he decided to find out how far we are from the Sun, how far we are from the Moon, how big the Sun, how big the Moon, in comparison with our Earth. Of course, you can imagine back in the day it was all calculated very roughly. We didn't have precise tools. People didn't use digital tools back in the day. So all the calculation was based on human sources like eyes and basic knowledge of mathematics. So how Aristarchus find out how far the Sun from us and from that figure out the size of it? The main enlightenment to him came from idea that Sun is the center of our solar system and that we are the body of the Earth rotating around it. Without that, he couldn't calculate it. Then he figured out that the Moon is another body which rotates around us, around the Earth, and together rotates around the Sun. Then finding the position of the Moon directly under right angle from us towards the Sun, 90 degrees, which he figured by looking on the phases of the Moon. When we see exactly the half of the Moon is lighted with the light from the Sun, twice into the moon cycle, we see it on both sides. This is the times when the Moon is directly under 90 degrees angle from the Earth. Astronomers call this position quadrature, or simply speaking, it's when the Moon is perpendicular to our planet in relation to position of us to the Sun, creating 19 degrees. Knowing the basic laws of proportions in a triangle with a right angle, we can calculate the proportions of the sides to each other depending on the angle. Now, modern days we know it as trigonometry, and we can easily put it values into the equation and calculate it. Back in the day of Aristarchus' time, they didn't know as much trigonometry yet, so he just figured out it himself, but just having complex calculations, which you can perform these days as well. He found out that the distance from the Sun till the Earth is 20 times bigger than from Moon till the Earth. Then by observing the solar eclipses, he saw the diameters of the Sun and the Moon always matching, and knowing the distance difference in 20 times, he could figure out the radius of the Moon. How it's proportional to the Sun, of course. Then observing the moon eclipses when our Earth putting shadow on the Moon, he could calculate then, knowing all these proportions and true size of the Earth, the approximate radius of the Moon. And he was quite close. He reckoned that the diameter of the Moon is 3 times smaller than of the Earth. Of course, all these parameters were approximate. You can imagine the degree of mistake there. But at least it gives us idea that the Sun is not just a dot traveling on the sky, but actually that it's far from us, and we had idea about the proportion of Moon, Sun, and the Earth. Since then, for many centuries, there was not much going on. Some scientists recalculated or adjusted the figures, but the significant recalculation happened in the 17th century. And only after Kepler and Newton come out with the main works of motion of the planets around the Sun and us as the Earth and the Moon, our satellite, the scientists start more precisely recalculating all these distances. Therefore, you remember that time a lot of voyagers went around the planet to observing Venus transit over the Sun or Mercury transit over the Sun, to trying to precisely calculate these distances and, more importantly, distance till the Sun. However, the equipment at that time wasn't as precisely as well, and our atmosphere on our Earth constantly disturbed those measurements. We couldn't very specifically calculate the angles, so there was always the mistake. However, pretty close, people knew about 148 million kilometers the distance from us till the Sun. In the modern astronomy, we estimated this number very precisely using the big radars and by shooting the beam of light towards the Venus and back, calculating the speed of it through the space, we could specifically know a very concrete number of our distance till the Sun. This distance from us till the Sun is very crucial to understand how we measure distance till other stars. Astronomical unit. This unit we've been using now in a method which is called parallax to measure the distance till outer planets, the closest stars and the distant stars. Parallax, it's the very basic concept. When you're traveling in a car, you see the trees and bushes and houses closer to you moving fast. The bigger objects like a mountain on the background or the sun on the sky seems like they stay in the same place. And this effect will depend on how far you are from the distant object, from the closer to your object like trees and houses, and how fast you're moving along your line, the baseline. This is the rule of the parallax, which people using to calculate the distance till far objects in the space. We're using our rotation around the sun is this baseline, so you in the car. We're traveling from one point to the other, the most distant point from the sun. For example, in the winter we're in one place, in the middle of the summer we're in a different place. By observing the movement on the sky of the stars and relative objects like sun or planets, we can figure out the distance, exactly similar like Aristarchus tried back in the day. Using the trigonometry, measuring the angle, we can figure out the distance to those objects. Unfortunately, it can work as far because this distance we're traveling from one point of the Earth to other, 150 million plus 150 million kilometers will be about 300 million kilometers. It will give us the limit how far we can calculate this longer line of your triangle and see the angle of the more distant stars. Some stars so distant it seems like they don't even move on the sky. And then scientists coming out with idea to measure the distance to closer suns. And then by the light that we observe from those distant suns, by degree how bright that light, we can approximately know if it's even further or closer to us. And that's when all these fancy and beautiful telescopes come in place. Therefore, you can understand that it's not as hard to understand how far the distant objects. You can practice this by using your both eyes, knowing the space distance between the eyes, knowing the distance between your eyes, bring the object in front of you like your finger, and observe some object like a tree at the background, moving from left eye to right eye, measuring the angle, and you can calculate the distance till that point. And that's what scientists do these days to estimate the distant objects.